As the editor of Science and as the president of the National Academy of Sciences, Marcia has made many important efforts to try to solve these problems and address these problems, most recently leading an effort to protect the integrity of authorship.
Thank you, Kathleen. So, good afternoon, everyone. Wonderful. Thank you. All right. So, Kathleen did a wonderful job of talking about the situation that we face as scientists with the natural tendency of the media to want to concentrate on the crisis narrative. And of course that's what they're going to want to say. Obviously, a headline that says, "Man bites dog," is going to sell a lot more magazines or newspapers than a headline that says, "Man sews up bad gash in dog." So, obviously, if we don't do something about helping to shore up our own reputation, we can't expect that the media is going to do it for us. Susan talked about the fact that reputation is a very fragile quantity. And if we don't protect our own reputation, we can't expect that it's going to survive. Reputation is something that we can build a long time trying to earn and lose very rapidly. So we have to act quickly to address all of the problems that Kevin just laid out for us. And as he also showed with the numbers he portrayed, the problem that I want to concentrate on is not so much problems of the actual misconduct, which is probably the lesser problem, but more the problem of these violations of the norms of science that we have to worry about, because it is the not actual fabrication, falsification, and plagiarism, but the smaller violations that are problems that creep into our work that can color the outcome and lead to problems in reproducibility and confidence in science. So here's my own list of what I would call the norms of science. And you might have your own, but this is what I came up with. First of all, as scientists, we want to base our findings on some kind of evidence, whether it's a theoretical calculation, whether it's data, whether it's a model, but some kind of evidence for our findings and conclusions. We expose our work to critical review. We share our work widely. We show our data. We're skeptical of our own results. If we aren't our own worst critics, there's something wrong. And we have to avoid bias. The results that we get should be independent of the investigator. I should get the same result if I do the analysis that any of you would get with that same data. Now, if we look at violations of the norms, when those norms are violated, this is what happens. We can get falsification, fabrication, or plagiarism, but we get all these other things that can be problems. Selective reporting, showing some results of some of our experiments, but forgetting to or avoiding showing the results of other experiments that don't tend to support our favorite hypotheses. Passing off a finding from exploratory research as having been from hypothesis testing. And that happens all the time, p-hacking, Or another example is undeserved authors, and we'll talk about that, where you can either leave authors off a paper who should have been on because you're hiding the fact that they were involved in the research when they might have had a conflict of interest, or adding authors onto a paper who shouldn't have been there because you want to try to use their prestige to get your paper published in some journal, or putting someone on because they insisted to be there even though they didn't do any work. All sorts of violations of the norms. So when I became editor-in-chief of Science, one of my crusades was to try to improve the standards within publishing to help work against some of these violations of the norm and make standards in publishing help authors maintain trust and integrity in science. So one of the first things that we did was working with the leadership at NIH, Francis Collins, Larry Tabak, and working with the leadership at Nature with Phil Campbell, we ran a workshop in which we called in the editors of a number of top journals and heads of major universities and a number of researchers. And at that time, because NIH was heavily involved in this, our focus was on the issues of reproducibility in preclinical research. And the results of this workshop were published in what was at that time had been only a handful of identical joint editorials simultaneously published in both Science and Nature that made recommendations for how to move forward to improve the reproducibility of preclinical research. And this was published in November of 2014, and the recommendations that became codified in, for example, a check sheet and recommendations for authors at both Science and Nature, and were later picked up in terms of the requirements in more than 500 other journals, was that there should be a pre-experimental plan for handling the data. In other words, you don't get your data and then decide on the fly how you're going to analyze it. You should have that plan ahead of collecting the data. That experimenters should do a sample size estimation to ensure they have appropriate signal-to-noise ratio before they actually, when they put their proposal in, because you have to have enough mice or fruit flies or whatever you need, and so you have to ask for enough money. There should be randomization in the sample treatment. In other words, the assignment of samples to the treatment group and the control group should be random. It shouldn't be, oh, this looks like a healthy one, we'll put it in the control group. This looks like a, or a healthy one, we'll put it in the treatment group, et cetera. It should be randomized which one goes in which. And the experimenter should be blind to which ones went into the treatment and which ones went into and which ones are in the control until after the results are known. And there should be complete transparency in reporting. If one of the samples was removed and you decided, I'm not going to analyze this sample, and you have a really good reason, you have to say so. I removed this sample because we found out something about this sample which was a legitimate reason to take it out of the analysis. So based on the success of that, in terms of getting so many of the preclinical journals to agree that this was appropriate protocol, we held a second workshop that was supported by our good friends at the Arnold Foundation to try to go even further in transparency and helping address the reproducibility issue in science. And with the wonderful work of the people at the Center for Open Science down in Charlottesville, we had a great workshop that resulted in this paper that was published in June of 2015 in Science on promoting an open research culture. And this came to be known as the TOP Guidelines, Transparency and Open Promotion Standards. And they were designed to support norms for sharing data, facilitating review and replication, and reducing bias. At this point, over 5,000 journals and organizations have signed on to these standards. So these are probably the most widely propagated standards on the planet for increasing transparency and increasing replication possibilities for science. And here's what the top standards are. There are 8 standards, and for each standard, there are a number of levels at which journals can sign on. There are standards for citation, standards for data, standards for analytical methods or code, standards for research materials, standards for design and analysis transparency, standards for pre-registration of studies, standards for pre-registration of the analysis plans, and standards for replication. And the beauty, well, the genius of the top standards was the fact that journals could sign on at a variety of levels, where the levels had increasing stringency. So, for example, with data standards, at level 1, all the journal might say is the author must disclose whether the data are available or not. And if they aren't, why aren't they available? At level 2, the journal requires that if you're going to publish in that journal, the data must be available. At level 3, the journal will say, not only must the data be available, but the journal will verify that the data have been deposited in the appropriate repository, and we'll check to see that it's there and can be accessed. And in some cases, journals have even gone in, accessed the data, and made sure that the data support the conclusions in the paper. So, since the top standards came out, we've held other workshops that have actually built on some of these. For example, this one, which the ever-talented Victoria Stodden led, was on computational methods, because compared to, for example, the number of repositories for data, many communities had good places to put their data. There was a lot of confusion as to how to promote reproducibility in computer codes. So this workshop, which we published the results just this past December, was on how to promote reproducibility in computational methods. And this was extremely helpful in helping people to understand how they could advance reproducibility in computational methods. Before this one, we had one on data in environmental areas, because there were some areas of environmental sciences, such as astronomy, or in field sciences like astronomy and oceanography, where data repositories were very, very well established and very mature, and other areas where they weren't, like ecology. And it was designed to help those that were well established to help others move forward. And some of our goals, I say here, were aspirational. Kevin already mentioned this Fostering Integrity in Research report. So I won't say much about this other than these detrimental research practices mentioned particularly about authorship practices. So the Annenberg Trust, which has the Sunnylands facility, made the estate available for us to have a small retreat to look at the problem of authorships and about the misuse of authorship in science and how that was leading to problems of conflicts of interest, hidden conflicts of interest, and undeserved authorship and ghost authorship, etc. This is a paper that's up on bioRxiv right now, and it's in revision for PNAS, which provides standards for authorships, lists responsibilities for corresponding authors. It recommends adopting credit, and a credit which is a method for showing what every single author did to deserve to be on the paper. And it recommends that every journal require that each author have an ORCID ID to identify exactly who the author is. And it recommends that institutions have regular conversations on what the criteria are for earning authorship on a paper. And we hope to see this soon in PNAS as soon as we get the revisions back. So there. And finally, I wanted to talk about this. Kathleen already mentioned this paper, Trouble in the Lab, that came out in The Economist. In the same issue of Science that had the top guidelines, Bruce Alberts and a number of other of us, some of whom are actually in this room, published a response to Trouble in the Lab, in which we talked about the self-correcting nature of science. And we made a number of recommendations. And I just wanted to update you on where we are with the recommendations. We talked about promoting increased transparency and openness in research, recognizing excellence in reviewing and providing more incentives for putting effort into review. We recommend creating at least 2 classifications of retractions to distinguish honest mistakes from fraud. Because labeling everything as a retraction, we feared was a disincentive for an author group that has an honest mistake from wanting to retract the paper. And finally, we recommended improving language in conflict of interest declarations to make it more clear. So where are we in all of those? Well, for the first one, the top guidelines, I think has done an excellent job of satisfying that first bullet. Number 2, I'm wondering whether we really need to do that. I think certainly recognizing excellence in reviewing is something that we should do more, and I was very happy to see earlier discussions about broader criteria for recognizing academic contributions. But we also have new formats, pub-peer, open review, etc. And so often at Science, the first way we'd find that a paper that previously had gone through review and actually already been published might have a problem was through a pub-peer reviewer. And they're really good about catching problems, so that's great. Creating at least 2 classifications of retractions. There's now a proposal at COPE to actually do that, which is, COPE is a consortium of publishers. And I think the last one is something we maybe need to put some more effort into, and that might be a subject of a future retreat. So thank you very much.